My name is Velenturf, and I'm a research fellow at the University of Leeds, working on one of the projects, which is transforming foundation industries. And I would like to introduce, for those who don't know, I would like to introduce Jonathan Cullen, who is with us.
Apologies, I've just moved office, and so I'm in a big general space. But welcome everyone. My name is Jonathan Cullen. With Mikhail, we started this RECBE about 4 or 5 years ago now, and it's great to see so many people turning up. Kind of Mikhail's actually been doing lots of work behind the scenes now to kind of do the agendas and get the speakers, so that's really helpful. Good. So resource efficiency in the construction, the built environment, you all know about this because many of you have been here, but anyone who's new to this, welcome along. This is our 9th meeting, so we've been doing that. Jonathan Cullen, I run the Resource Efficiency Collective at Cambridge. We're now about 18 people at the moment, so a lot of people working on this problem of delivering energy and material services, but using less energy and reducing environmental impact. And so this RECBE initiative looks at that particular problem for construction. We have a website, the Resource Efficiency Collective, and there's quite a lot of information on there about RECBE. So that if you find the one down the bottom left there, you can click through, and we have all of the slides and talks from the previous meetings as well up online. And the idea of this, so we launched it in 2018, was really about just bringing together academics, companies, people in the construction and the built environment space to talk about interesting research and what's going on, and to look to do these workshops a couple of times a year, and to also build collaborative research projects between people, not in a particularly organized way, but in a way of just meeting people. And lots of companies represented, many of you who are on there. Apologies if your logo isn't on there, but lots of companies working. And agenda for today. So welcome from me, and then we're going to move straight into hearing from Velenturf and Poole, and doing some discussion after that. We've had some speakers drop out because of COVID, as Mikhail said, so there's a bit more time for construction for some discussion at the end, so that'd be great.
Yeah, so thank you so much, Jonathan. As Jonathan mentioned, unfortunately, Kai from UKGBC today, unfortunately, told us he has a COVID and he couldn't deliver the presentation, so I'm very sorry. So we had slightly more time for discussion. We can then discuss what we might do to help the industry, or how we can accelerate some kind of changes, what the RECBE members could be involved in, what the projects are running. So those kind of things could be, so today is a really good place to share that kind of information and to be up to date with many different initiatives. So I would like to ask Anne to present the first presentation. Anne is from the University of Leeds, and Anne works at the TransFIRe. So Anne, I'm giving you the screen.
I have sharing abilities, so
yes, you should have.
Yeah, so the slide should be with you now, and I will apologize up front because my laptop is incredibly circular economy. It's about 10 years old, possibly worse, and it just means that for some reason my slideshow function doesn't work anymore in meetings, so we have to just do with this. So thank you, Mikhail, for inviting me today. So as Mikhail said, I'm Anne Velenturf, and I'm a senior research fellow in circular economy at University of Leeds, and I'm also the technical program manager of TransFIRe, which stands for Transforming Foundation Industries Research and Innovation Hub. And today I'll talk about how we can link the circular economy strategies onto a move from reforming industries to transforming industries. So TransFIRe is a proactive research and practice driven hub that supports foundation industries to generate more value from less resources. Foundation industries, we focus on 6 of them. We focus on ceramics, metals, cement, glass, paper, and chemicals. And we bring these foundation industries together with their stakeholders through interdisciplinary research to support resource productivity, competitiveness, climate action, and also equal opportunities for people and communities as well. And in this way, TransFIRe is facilitating transformative change in the foundation sector. So today I'll speak about what this transformative change includes from a circular economy perspective and what opportunities such transformation opens for companies. So circular economy, it has been defined in as many people as there are people working on circular economy, but there are a few commonalities, thankfully. Is of course the opposite to a linear economy in which we take things from the environment, make something from it, use it for a short while, and then dispose of it, often in unsustainable ways. And in a circular economy, we aim to make better use of those materials and the components and the products that we make from them. And in my view, that has to include the minimizing of resource input from the environment, maximizing of waste prevention, and then optimizing environmental and social, material, and economic values of products and components and materials throughout their consecutive life cycles. So when we say optimizing, we're doing that usually for some purpose, and in a sustainable circular economy, that purpose is to increase social well-being and environmental quality while maintaining economic prosperity. And if we do that, then there's lots of benefits that we can realize together. For example, in the UK, we could generate nearly 500,000 jobs by 2035. Many of these jobs, about 300,000 of them, would be in remanufacturing. Whether we will get there with this government, I suspect it will be heavily thrown off track, but hopefully it will still be possible if we get a different political climate. There's also high potential to reduce greenhouse gas emissions globally. It could reduce by more than 60% by 2050. And it can generate very substantial business opportunities. Now, these estimates for business opportunities, they vary greatly, but in any case, they are incredibly substantial. That is a thing that is certain. So circular economy can be implemented through a number of different groups of strategies. And the first group is about narrowing resource flows. So this is about reducing the amount of materials that we have in our society as a whole. And we can achieve that through better design, for example, modular design, design with less materials, but also shifting to business models in which, for example, we don't sell the products, but we rent them out or we share them. Then there's slowing resource flows, which is about extending the amount of time between the moment that a product is produced and the moment that it goes to waste. And there are various actions that we can take there, such as component reuse, repair, remanufacturing. There's a whole list here of dozens of R strategies that we could raise, but I think these are the most important ones. Then there's closing loops of resource flows, which is essentially about recycling materials and strategies such as industrial symbiosis. And then it's also important to recognize that actually it may not be possible to keep circulating resources within our society in a sustainable way forevermore. Sometimes we'll have to reintegrate materials into natural processes, and that has to be possible in a safe way. And that is what the last group of strategies is about reintegrating resource flows. So within the circular economy community, there has been a tendency to focus mostly on recycling, unfortunately. And while this kind of strategies will help to improve the current production and consumption practices. And it really fits very well into focus of increasing resource efficiency with new technologies. And while that is really positive, it largely leaves production and consumption processes unchanged. And with a belief, and that is really with a belief that economies can continue to grow, but in a green way. And green growth, it relies on decoupling of resource use from GDP growth. But scientific evidence has shown that decoupling is not happening sufficiently, it's not happening fast enough. In other words, empirical evidence is suggesting that green growth is very unlikely. And as a result, a growing part of the circular economy community is looking to enable deeper transformative changes to our economy and our behaviors. And the key difference between those mainly focused on recycling and those aiming for a sustainable circular economy is that the latter are mainly focused, sorry, lost that track in my notes, is that the latter, when you focus on a sustainable circular economy, is that we have added a major focus on dematerialization. And in a country like the UK, that means that average resource use per person may have to be halved. Now, given that 75% of the materials in our economy are coming from foundation industries, the impact on those industries can, of course, be really substantial. But equally, do remember the massive opportunities that I mentioned earlier as well in terms of business opportunities and jobs and for the environment. So TransFIRe is supporting a shift in gears in the foundation industries from reforming to transforming, as is indicated on this image. And we do support reforming of practices, of course, because this is what we are starting from. And we are doing that by minimizing resource use in manufacturing processes and by supporting innovative industrial symbiosis. And these are mostly technical changes that can substantially improve the current models of production. And that is really important too. But at the same time, it's important to continue to move towards transformation as well, in which we are rethinking more radically how we can change our production and consumption models. And it's really starting from the point of asking, why are we actually producing, consuming in this way? And can our needs perhaps be met in a different way while we are generating more value for people and environment, while we are maintaining our economy? And, it is also about making sure that our industries are future-proof as well, while our environment and our entire social context is changing. So transforming foundation industries will be a gradual step-by-step process, is what we expect, is what we're aiming for. But today I also want to make the case for leapfrogging ahead and not to invest ourselves entirely in a recycling economy at the scale of the current resource use. So based on extensive, excuse me, still the remnants of COVID in my lungs there. So based on extensive cross-sector context analysis that we've carried out with the TransFIRe team, we found that investment is one of the major challenges for transforming foundation industries. Currently, foundation industries in the UK are competing globally, producing against ever smaller margins. And this leads to a race to the bottom. And there's a lower likelihood of investment in UK sites, and that has a number of reasons. For example, sites tend to be older and therefore less productive. Trade arrangements are uncertain. Costs can be higher due to stricter regulations and energy prices. And capital availability at the same time can be low in the UK. While innovations in the foundation industries will, of course, cost billions just to modernize sites in the UK alone. Now, it seems unlikely that UK sites will outcompete sites in, for example, Asia or even mainland Europe. So when sticking to the same, and that's under the conditions of sticking to the same business model. So in other words, staying on the same pathway by only reforming practices will postpone loss of foundation industries in the UK, but it will probably not stop it. So we could turn the tide with a number of strategies. We have a few ideas, but very much open for other ideas as well, of course. So we could retrofit sites with relatively more affordable innovations. We could collaborate across foundation industries and across supply chains so that we can share costs and risks of the changes that we have to make. Could diversify circular business models to radically more circular practices to escape global competition. I have a few ideas about that in the next slide. And crucially, it's really important that we do all of these changes as soon as possible while there is still some cash flow available, maybe, in the UK, and that we do not put all of the eggs into the recycling basket. So some of the transformative circular business models that I think are going to be growing, well, under the current political circumstances, nothing seems certain anymore, but I think that there's going to be growing demand for this from the market and from society, regardless of government. And the first is about remanufacturing and other component and product strategies such as repair and reuse. And this can be aided substantially by modular design. So modular design is really important, as is durability. Reusing materials, components and products, it depends on quality assurances, which depend on supporting data systems. These could be coupled with recertification services to boost confidence. And all of these are really great business opportunities. The last one I want to highlight is disassembly, because this is often the overlooked strategy in circular economy. But it's actually essential, for example, for remanufacturing, for high quality recycling. And disassemblers will also gain through their activities a really good understanding of often commercially sensitive information about what is in products as well. And I think that this will also be a source of income. I think this will be highly valuable. So to conclude, circular economy is definitely broadening well beyond the idea of just closing the loop. And there's a growing group of us calling for scaling down our resource economy with deeper changes to our economic system and our society. And this signifies a change from reforming to transforming production and consumption systems. So foundation industries in the UK are caught in international race to the bottom, which in my view, they are unlikely to win, but there are opportunities to diversify into business activities for which there is a growing demand from supply chains, such as remanufacturing, and such activities will give a higher return. So there is a growing pressure from society to transform business practices and substantially reduce carbon emissions. And also when we look at the employment base, young people, they want to have green jobs, and transforming foundation industries will also deliver on that. So that's it. Thank you for listening to some of my perspectives on transforming foundation industries and how they map onto a sustainable circular economy. If there's time for discussion and questions, it's be very much welcome, of course. Thanks, Michal, for inviting me.
Thank you so much for a very interesting presentation. I know that we have scheduled the discussion session after two presentations, but I think we can spend a few minutes just for a few burning questions regarding this presentation. Thank you so much. Are there questions in the room? From this side or from that side? Yes, sorry.
Hi, thanks very much. That's a really interesting presentation. I was wondering if you could say a little bit about, I was looking at your presentation. I was wondering what's the role, particularly for policy here, in creating a business environment that the sort of opportunities that you talk about to be realised are in a sense sort of the main or the only options, given that a whole sector of the market needs to be cut out in some way or another to enable these sort of strategies to develop. Because in a current sort of open market, the type of the business case for adopting the strategy that you mentioned is an incredibly risky one.
Yeah, I mean, that's a good point that it's risky. Of course, I mean, there are definitely risks, but there's also high risk of doing nothing. But just to answer your question about the role of policy, I mean, there's a lot that government can do, and certainly government measures are absolutely essential to make this happen. The first thing that they could do is actually set more ambitious targets for circular economy. We have seen that will have that has an impact in the past. This is a policy measure that can work. There's of course a really important role in terms of creating demand. So in updating procurement guidelines, for example, because the government itself is a really important customer as well from UK markets. And I'll leave it at 3 today, but there's a lot more that government can do, of course, but it's also really important that we have a facilitation program again, and not just a facilitation program like we have seen in the past for business support, for industrial symbiosis, but for facilitating circular economy in general. Because circular economy innovations, they are a bit different than the the normal sort of technical and normal business improvements that may have been supported in the past. And that is because circular economy innovations, per definition, involve more than one actor. So you always are innovating together along the supply chain. And that makes it more tricky, makes it more difficult for a company to initiate that, especially if you are an SME. So it's really important that we have a good support program for facilitating circular business model innovation.
And there's a question in the chat as well from Mark. I don't know if you can see that, but his question was, how do you see this fitting in with systems thinking? And I think that leads on from what you're just saying, but do you want to respond to that?
Yeah, I would say which kind of system thinking, but no, sure. I mean, this is all about whole system change. You don't just change one bit. If you want to move towards sustainable circular economy, then you have to change the whole system. But this is sometimes also then what makes it feel a bit impossible to achieve. But actually what we have done in our research, and within TransFIRe, we're still getting there for the foundation industries in particular, but what we have done in the past for the whole of the UK is actually analyze what does that system look like of drivers and barriers for changing the whole of the economy towards a more sustainable circular economy, and then which actors are in control of particular points where we can basically do a bit of karate, I suppose, to kick the system into action, and to Aikido would be more appropriate there, but to basically trick the system onto a transformative pathway. And we have done that. Unfortunately, this government has taken away most of the measures that we had successfully put into place, but that doesn't mean that we didn't do it in the first place. So it's possible in principle. Just by identifying how this network of drivers and barriers works, and to find the key connections in that network, if that makes sense. I can post a paper in the chat, which may actually demonstrate this a bit better. So you can look it up. But basically what we're looking for is just like a handful of actions that we can take to tip the whole of the system onto a transformative pathway.
Great. And I had a question, so when we think about circular economy, it's often being framed more in a kind of a product-based space. And obviously construction feels a little bit different. I mean, you can argue a building is one very big, complicated product, but can you talk a little bit about some of these strategies and how they might actually apply in construction and the built environment where you've got very complex, large buildings, essentially?
Yeah, I mean, of course, I do not have a background in construction, but there's certainly a parallel here with the wind industry, where you have these massive wind farms and wind turbines in there, which are basically, we're talking about whole pieces of infrastructure, and not so much, I agree with you, Jonathan, not so much a product, even though it is sort of like a giant product, but it's very much the different scale, right? So most of the circular economy strategies, they do not apply at the whole infrastructure level. And this is an area where I feel that as a circular economy community, we really need to do more research. We need to investigate it further. And in the wind industry, there are strategies that do work at the whole infrastructure level, such as extending the lifetime, or in the case of turbines, replacing them with better ones or bigger ones. And also, of course, there's the whole removal of infrastructure as well, because sometimes we have to decommission the entire infrastructure and either build something new there or restore the area back to some favorable environmental conditions. But this is absolutely an area where it's actually, I feel it's a bit of a gap in the research. But I think in construction, there's probably a little bit more going on that we can learn from as well.
Any other questions, or before we move on?
Yeah, there's one question from the room.
Perfect. You take it, Mike.
Yeah. Thanks, Anne, for the presentation. My name is Sam Kandi, and my question is from the academic point of view. As an academic at Coventry University, just a few years ago, we were asked to develop modules or include in our modules the sustainability concepts in engineering. I'm from civil engineering background, and my specialization is geotechnical engineering. So we were actually, it's a terminology that we weren't very used to, and then we're being asked to include sustainability in our modules. So as a geotechnical engineer, I'm trying to, what should I tell the students about sustainability? And now we are hearing of other terminologies moving away from sustainability as not being sufficient enough in describing what we want to achieve. We're hearing about regeneration, and now there is transformation, there's a circular economy. You feel, Anne, that all these terminologies somehow are kind of confusing and distracting from what really we're trying to achieve, and that we should make it a little more clear for everybody.
Yeah, I mean, it is really confusing, and definitely within circular economy, there is dozens of R strategies, for example, and they all being used in different ways. For example, well, the main ones, reuse and recycling, are confused with each other all the time. So, I mean, it is clear to be, it's important to be clear about what we actually mean and to call a spade, I think. But at the same time, I also feel that what you are describing is maybe the evolution of knowledge and insight, and I think that is inevitable and probably actually important. I mean, sustainability, like circular economy, has also been defined in lots of different ways. It's being used in many different ways, and often used in really poor ways for greenwashing purposes, which is perhaps why people are now looking for alternative words to describe what they're doing, because they don't really want to affiliate, or they don't feel like sustainability is enough. But in principle, sustainability should, of course, be fine as a terminology, and we shouldn't necessarily have to move away from that. Yeah, just actually linking these two things together, your question and the comment before. I mean, I think that overall we have to move towards reducing resource use in the UK, and we have to move towards greater durability and using things for longer. That is the way forward. It's not just recycling. Recycling comes at the end of the chain, and not, the first choice, as it often is at the moment. And unfortunately, that is an evolving insight, which may need to be updated in teaching. But I'll admit that I am not much involved in teaching, so I'm not sure if I can say too many insightful things in that regard.
Great. Simon, did you have a question as well?
Thanks, Jonathan. Yeah, so afternoon, everybody. So I've been invited to some training next week by the Concrete Centre, and the title is Getting Closer to Net Zero Using Concrete. So there's a launch of a new concrete decarbonisation task force. So we've been talking about, concrete and resource efficiency action plans for maybe a decade now. Do you think the amount of CO2 per ton of carbon has gone down? Has it gone down by much? Is it a 10% reduction? That's my first question. Second question, is it really possible? Is it just disingenuous to talk about concrete and getting closer to net zero? I'm sorry, for me, that's just disingenuous, but I'd be grateful if anyone's got any, sort of ballpark figures. Yannick?
This seems like a great question for wider debate.
Yeah, I was going to say maybe Yannick or Mikhail or someone, Cyril. I don't know if anyone wants to pipe up and answer that.
I could answer on the cement. So the carbon intensity of cement production globally is still going up.
It's still going up.
I can share the source and a link to that, the details.
So Simon, I produced a link, 2 pages of the description about the carbon intensity of cement used in the UK in general.
Okay.
To have a chat with you. From my perspective, I think it's really hard to reduce significantly carbon emissions from cement and concrete. However, we have a Cyril here that could be.
Well, I'll say I'll say some things on that topic later on in my presentation, but. Okay. I think here it's important to distinguish, by the way, the intensity of cement and the intensity of concrete.
Yes.
It's not something we talk very much about, but of course, using the same cement, the carbon intensity of concrete can vary by a factor 3, depending on how it's been deployed on site. So, although it is always useful to reduce the intensity of cement, there is it has to be, you have to distinguish it, because cement is this thing that's hidden from the user, which is the people on site and the designer and the structural designer. They care about concrete. Yes, cement causes the concrete to be carbon intense, but you can have lots of cement in your concrete mix or little cement in your concrete mix and broadly the same performance. So that's just something to keep in mind.
Yeah,
I guess the broad lesson in general is even if it's hard to know what the actual carbon factor is, it's always good to use less of it.
Wise words. Yep.
That's totally true. Yeah. So I'm really happy to have a chat with you, Simon. Maybe next week or the week after. But,
all right.
As Cyril said, we can, the carbon intensity per cubic meter of concrete can vary between 60, 70 kilograms per cubic meter up to 300 or maybe even more. So having the same properties or the same or very similar durability properties or that kind of thing. So it's tricky, but there's ongoing conversation about it, and even this decarbonization or concrete decarbonization task force is looking at this exactly the same topic. So how to use less concrete in the first instance, and then reduce the amount of carbon in every single cubic meter which is added to our environment. So there are 2 different, they are looking at it as well. So it's not only about using 70% of GGBS, which is perceived as a low, or the byproduct with a low carbon concrete material, but of course how we can reduce the amount of stuff that we produce. So this is a slide that I hope answered your question, but this is the idea of this task force.
Okay, thank you.
Do you have any other questions for?
Glenn just had a hand up, and so we'll take that last question, and then we need to move on to the next speaker.
Hi, thanks. Sorry, it wasn't quite going to be a question. It's just going to slightly build upon that exact conversation in response to Simon, and maybe provide a little bit of on the ground kind of reality of where we've got to. So I'm an R&D leader for Langer Walk. So building on what Michael's just explained with regards, the volumes of cement replacement materials, etc., the short-term opportunity to decarbonise concrete, reduce the amount of cement used.
Yeah.
When you look at that in the system space, I've just prototyped and developed a system with Arup, we've reduced 70% of the amount of material in that system. A similar system and approach was taken, was recently prototyped up at Cambridge with the Acorn project. So if you've got a superstructure system that's using 70% less material, 70% less material, plus you've got a concrete that you can reduce the amount of cement in it and get an embodied carbon reduction by 70, 80%. You know, that system that I can go literally build today on a project is an 86% reduction compared to the kind of very thin PT slabs that we're currently building. So there's huge opportunity gains. And then when you play that through, if you look at, say, Hanson as a cement producer's decarbonisation roadmap, and they have carbon capture and they have green hydrogen. So
I don't think they do have carbon and capture.
Well, they do, because they're piloting.
Be very careful. Do prove that. I'd be really
in the long term. And I think this is the key piece. If that's available, and it will be available, but in very small amounts.
Okay.
And the carbon capture of that is 5 times the cost of the cement works type. It's going to be a very, very small constrained amount of potential net zero cement. And so, if I have to therefore think about design, I have to use cement replacement, say that's calcined clays, 40% cement replacement, a very small amount. I need 80 or 90% less material, which goes back to Anne's presentation, in the overall system. And then you can see a feasible, I'm using maybe 5% of the cement that I'm currently using in the industry today. But I've got to add all these bits together to get anywhere close to being feasible. We can't just use materials as we do today and expect the numbers to stack up. It's just a nonsense, But if I'm using only a few % of what I'm using today, then you can start to get things to stack up, as well as use circular thinking, like, really building upon what Anne was saying earlier, to actually, we've got loads of material and cement and concrete products out there, so we use them for new build. So there's real viable routes and huge opportunities we can make literally today. We need to be doing so.
So if I may add something to that, I don't know, Glenn, if you are aware of this low carbon concrete roadmap from Institution of Structural Engineers. So that was published in April this year. So that includes all the things, maybe not in a very detailed way, but that includes all the strategies that allows us to minimize the carbon impact from concrete. So from the structure efficiency, so from even from the layout of the, from the structure efficiency, from the choice of the different slabs or different floor types, to the minimization of the carbon in the concrete that should be half by that. So this is that kind of thinking as well in the concrete industry. But this roadmap was also one of the call was one of the cement producer. So the cement producer recognized that, and he agreed on the statement that is in the roadmap. So that's a really good step. So it's not. There are lots of different levers that allows us to reduce. And first of all, is the choice whether we build or not, and then how we build, what materials we use, and so on and so on. So that is a really good point. Thank you.
Yeah, I think we're moving off eastward. We're talking about circular economy and reuse, not about upfront carbon.
Yeah.
So should we stick on the circular economy? That's what Anne was talking about.
Okay. So if you don't mind, let's move to the next presentation. Ian Poole on the structural plan of work, sustainability report and checklist. That's a more technical thing. Thank you so much, Anne.
Cool. Thanks, everyone. So I have to start with an apology in that this isn't directly related to circular economy. I think the original plan was to have Penny Gala talk about the publication that's coming out in a few months' time for the IStructE that she's writing with several authors on circular economy and reuse. But I think that's been pushed back. So I'm here today to talk about the sustainability report and checklist, which we produced over the last 12 months for the IStructE. So hopefully you're interested. So So it's a template report to add project-specific information based on work undertaken to increase the sustainability of the project. And really this comes about because a couple of years ago, the IStructE released the structural plan of work 2020. And this was aimed to provide a new framework which aligns to the legal plan of work but gives specific information to structural engineers. So to define the wills and deliverables at each stage, and also mainly to provide clarity to clients on what we should be producing why. So I think for a while we've kind of gone through different practices, have done different things at different stages, and it's incredibly hard for our clients to understand what they get and when, and to put things together and develop consistency across the industry. So I think that's the background to the structural plan of work. But why it's interesting for anyone in the sustainability field, which is hopefully most people at this stage, is that they introduced a new deliverable for structural engineers. So this is something that we wouldn't typically have done historically, but it was to produce a sustainability report or a sustainability section in our reports, where we can outline everything we've done to make the project more sustainable, to reduce carbon, and to improve the economy either we use now or kind of safeguard in the future. So the aims of putting the template together was kind of response to the need for engineers to do something but not necessarily knowing how. And the template therefore provides a standard scope for sustainable reporting. So trying to get uptake across the industry, so doing consistently and saying consistent messages to clients. I think from what I've seen over the last few years, there's been a lot of different messaging and different assumptions people are using. So I think it's really important that as an industry and as a profession, we're giving the same information to our clients. The next thing is to provide best practice. So I'm discussing the IStructE here, but across industry, I think there's been so much publication and output in this space in the last few years, it's sometimes hard to know where to go. So the idea was to try to bring together the best guidance that had been produced over the last few years into one place. The next part of it was to record design decisions, principles and development that are kind of driven towards a sustainable structure. So this is really the detailed report. The next point was to inform those constructing using retrofitting and deconstructing the structure about what we did in the design. And again, I think something we often see is that in the design team meetings and the design progresses, you'll have the best intentions, but it's often can go wrong side if decisions are made at the last minute or those constructing the building don't know the intention of design. And this is particularly important with the economy in terms of, say, how you detail your steelwork connections, so it could be dismantled in the future, for example. And then finally, just going into the construction stage, promoting sustainable specification, procurement of materials. Again, I don't want to get completely into discussion about concrete and steel and low carbon alternatives and everything, but again, I think there's a lot of mismessaging out there at the moment. So just trying to give everyone the same information and present that information consistently to clients. So I won't go through the entire report, but I'll just show the kind of how it looks and the format of it. So in general, we've structured it so that there's a lot of text in there at the minute, which we've written, which hopefully is usable. So people haven't necessarily got the resource or the time to go through and write this from scratch. They can just take what we've written, adopt it if they need to, but that kind of explains what the report is talking about. And then we've got placeholders where everyone can input their project specific information.
Both to
and finally, on that, there is in the comments of the report template, there's a list of kind of guidance and general recommendations of what should be put in each section. So as you go through it, you kind of, especially the first time you write it, you kind of know what you should be writing and where to go, where to find things. So for this example, looking at the client's ambition and policy requirements, directing people to look at ESG statements that their client may have made, local policy requirements on the like carbon reporting, so statements, etc. So everyone kind of understands the wider context of what they're doing. So I'll just briefly go through the sections of the report and what kind of things in there. So we wrote an introduction section, which is largely there just to be kind of copied and pasted, just informative really, and setting the scene. So we're touching on the SDGs, then go into more detail about defining carbon and the life cycle assessment, a brief overview of the importance of embodied carbon and the increasing importance over time as we decarbonise operational energy, and then finally introducing the actual hierarchy of the use less stuff, and that kind of build nothing, build less, still clever approach. And then going into a bit more detail about the more wider sustainability considerations, so circular economy, obviously, and biodiversity considerations. And then finally, the section I gave us the example at the end of the introduction, we just got a bit of information around thinking about what the targets are for the project, drivers, ESG commitments, standards, and targets that the client might be going from. The next part of the report is, so we've written it in a way that it's not necessarily, it can be used at any stage of design, so either 1 through to 5, but it's kind of written in a way that you fill it out as you go through. So this next section is mainly aimed at kind of Reader 2, where you're making the key decisions on the brief and how you deliver a structure to meet requirements. And in this section, we just really gave an overview of the key structural decisions that need to be made and the considerations that can be made early on to reduce carbon. So we talk about structural grid, obviously reducing the space between columns being a significant benefit, trying to reduce the amount of basements and the amount of work we do underground because of the additional carbon intensity, considering floor heights and making sure there's an allowance there to make an efficient structure, so not to be pushed and squeezed into doing something really efficient. Then talking through column alignment, so trying to avoid transfer structures, which again are very efficient, and cantilevers in a similar way. And then discussing loading serviceability requirements, trying to get those right early on so we're not over designing our buildings penally because we're over specifying what they have to be designed to. And then a section also on materiality, so getting the right material in the right place, which is where we often go wrong right at the start of the project as well. And then we go on to discuss what we kind of term more whole life cycle considerations. So this is where we discuss whether reuse is feasible, whether the building, if there's a building on site, how much of that can be reused, if not, either the materials locally or that can be procured to reduce the amount of new materials used on the project. Again, thinking a lot about materiality, and then also thinking about flexibility and adaptability. So I think historically the way we've approached buildings is to put a 5 kPa load everywhere and try to open up the columns as much as possible and say this can be used for many purposes in the future. But a much more targeted strategic approach to adaptability can achieve much better results at much lower overall carbon costs. So think about, are there places in the floor plate or in the structure where you could potentially strengthen in the future if they need it, or where you're allowing extra capacity for different purposes without over designing everything. And then similarly on durability and circularity, so this is another area that's often hard to understand and develop as a structural engineer, because for a more durable structure you might need to put more material or more carbon in initially, but that might be suitable for a structure that we know is going to be around for 60, 80, 100 years. Whereas if you design a structure where there's a lot of uncertainty around its use going into the future, then you really need to think more about how it may be reused and adapted in different ways, taken apart, made smaller, made bigger, etc. And I think that's a really interesting thing to get, an important thing to get right for the project. And then in this section, we also talk about resilience, climate resilience, what considerations we're making to the future, adaptation, and finally innovation. And again, just thinking about that earlier in the project. So it's it's something you can progress through the design, and you give time to actually mature through the design. The next section is on carbon calculations. Obviously, there's an incredible amount of stuff in the industry at the moment, but I think across the practices, even in the structural engineering disciplines, everyone's doing things slightly differently. To me, the important thing is to kind of share everything that we do, and also be completely transparent in the assumptions we've made and the scope of our assessments. So we're putting some tables here to try to capture and make it both the scope of the assessment, the assumptions in terms of how much material has been included in the assessment, and then the key assumptions made on materials, which we know affects the carbon calculation a lot. And obviously that kind of ties back to reporting on scope metrics for structural engineers, or more broadly on material targets for the project team. Yeah. So the next section kind of builds on from the setting the brief, which was kind of the overview of a lot of this stuff. And then this is kind of filled out, the design approach filled out through more through read 3 and 4 in terms of how the designs actually look to achieve the brief. So going into more detailed consideration of the criteria set, considerations around the loading used and the serviceability criteria. And this isn't meant to just repeat what we already produce in our reports, where you'll have a 3-page table of all the loads considered, but just consider some of the key parts of it and what that means for sustainability. Some of the example I gave earlier, where you may have increased loads to allow for future adaptation, or areas where there might be more suitable to stricter vibration requirements, again, for either for future or current use. So really kind of responds to the kind of use of the building. Consideration of other disciplines. So I think often we think quite in a siloed way, but there's obviously times when we might need to increase structural material to help reduce material of the facade, or to reduce the amount of services that go through the building. And I think that's worth capturing in our report, so that we become more aware of that, and we also think a bit more broadly about decisions we're making. And then finally in this section, obviously just discussion of solutions, configuration of the building. And again, just kind of focusing on the sustainability aspects and the bits that matter for that, rather than the detailed structural stuff, which will be in the design report anyway. And so finally, the construction approach. So the last part of the report really talks about how do we go from what we designed to what gets built as efficiently as possible, communicating the information, making sure there isn't a performance gap between what we're thinking we're designing and what actually gets built. So the specification, kind of linking into the requirement for EPDs for the materials we procure, tying in some of the industry initiatives, Steel Zero and Responsible Steel, and the work that the Low Carbon Concrete Group have done, and trying to use that as a framework to do things consistently in the way we specify. The next part is on the procurement, so the impact we can have through the tenders, incentivising things like research and development, and proposals for contractors to reduce carbon emissions as well, and take the design further. And then finally, I think one of the really important things which I mentioned earlier as well is enabling use and end-of-life benefits. So things like, is there testing or monitoring that can be done on the building to inform future usage? Can you feed, if it's a steel building, can you feed that into some sort of database or share it so we know what steel's in there and what might be available in 30 years' time if it does get deconstructed. Detailed requirements to match the intention of the design. So, for instance, if it is going to be dismantleable, making it very clear which connections need to be detailed in a certain way, and making sure that's communicated. And then finally, information sharing, which I kind of mentioned above as well, but from my experience on previous projects, we often over-design a lot because we kind of hide information from the people building it, which is really ridiculous when you think about it. So can you give the steel fabricator your model and they can design the joints, the actual forces and moments that go through those joints, rather than us rounding everything up, rationalising everything, and then over-designing all the connections in the structure. So yeah, that's basically everything. The QR code on the screen should take you to the report where you can access it and download it. It's on the main page of the plan of work on the IStructE. And similarly, alongside the report, we produced a checklist. The aim of the checklist was made to make sure that, at least in the initial stages, people aren't going in to write a report at the end of the stage and then they don't have anything to write because they haven't considered anything. So the checklist is there. It's a really useful guidance. It's online, so it's just a single page with one drop downs, and it just talks through the entire process. What things should you be considering at different stages? What's a good resource to go and read if you don't know anything about it? And yeah, I think it's just a brilliant place where engineers can go, well, others can go as well, to just find out a bit more and understand the key things they need to consider. That's it.
Thank you so much, Ian, for the presentation. And do we have any questions for this presentation? We are like a lot of time. So if we have one or two questions, quick questions, we can have them. If not, we can move to the next presentations. So if there's no questions, I think maybe I have maybe one very small question or a very short question. Do you consider any post-construction assessment of the solutions that you've taken into consideration during the design process?
In terms of
Sustainability,
on assessment of kind of
or building that was started 5 years ago, and do you have some kind of checks for your assumptions and your design assumptions or what were important?
Infrastructure needs more. We rarely monitor buildings or have anything to do with them after they go to completion. Obviously, with occupational energy, we see more of the neighbours scheme and other things to track that over time. And I think, yeah, possibly it will be something that we start to introduce.
Okay.
In isolated cases where, especially where vibration is going in, they start to look at using monitors and installing systems to track that.
Okay.
And I know, just thinking back to people in this group, and the night stuff from 5 years ago is talking about why don't we actually measure how much stresses we're getting, how much load it, and I think it's a very small cost as well. Some sensors and a certain number of people. I like to see, but I don't know if anyone else on the call has any experience with that.
Okay. Thank you so much for your presentation. I would like to move to the next session, and I would like to ask John to lead the next session. The next session, we have very short 3 presentations, and is John taking over.
Great, thank you. So yeah, in this next session too, we've got Roy Fishwick talking from Cleveland Steel and Tubes, Cyril Dunant, who many of you will know from Cambridge, one of the RAs here, talking about a new idea that they've patented called Cambridge Electric Cement, and then Les Alabi, who is talking about recycle, reuse and repurpose from power sim technologies. So Roy, can I hand over to you?
Sure. Can you hear me first? So I've had everything switched off.
That sounds great.
Excellent. Yeah, first off, my apologies. I'm actually in a pub in Middlesbrough because we got hacked by some Russians on Wednesday night, so our entire IT system is currently subject to ransom. So on the top of the various other issues I have going on at the moment, one of them is no email or IT. So I'm robbing the broadband from Green King or somebody. So that's, I apologize if you can hear music or sports events in the background, but it's the best I can do just now because my broadband's rubbish at home. So structural steel reuse, I know there are a few people on the call and I've seen a couple sitting in the room that know me very well. We've been involved with this for a lot of years. Mikhail's asked me just to do a potted summary. So apologies because it really is going to be whistle stop. The first point I really wanted to make, and it's very obvious, especially with foundation industries, but it's the embodied carbon and the impact that can have. We're looking at 0.5 megawatt of solar on our premises, which will save us 7 tons of carbon per annum. The 18,000 tons of steel we sell every year potentially saves 40,000 tons of carbon. So that's the impact. And steel has a very, I know there's route maps to zero or a much lower carbon product, but in the current here and now, there's not much of that available in any of the products, in my opinion, to solve today's problems today, which is why reuse is such a powerful tool in lowering carbon. Just to mention that from my perspective, I've been involved, and Jonathan, I remember this from donkeys years ago as well, but it's about 10 years I've been banging on about steel reuse. The difference in the marketplace in 2022 is phenomenal. The amount of activity, the amount of interest in business, in construction companies, in demolition, in recovering materials for reuse and incorporating materials into buildings for reuse. The growth is astronomical in terms of the interest in the last 9 or 12 months. Anna has already alluded to this. Is recycling enough? Steel, no, because it's already all happened. Steel is 95% recycled steel, Sorry, forgot to mute my phone. So the reuse is the quickest current solution where it's available. Steel's properties don't deteriorate if it's protected from the environment and you don't cause it physical damage, radioactivity, fire, or fatigue, or basically mangle it when you're taking it down, because that is another factor. But steel is a great material and has been identified as such to be used again and again. The basic maths, it's more or less agreed now that reusing steel can save 95+% of its carbon. There's an EPD from EMR. We've done work with Elliott actually, looking at the carbon cost of reused steel, the recovery of it. The carbon cost of demolition wasn't included particularly because the building's coming down anyway. So it's sort of can be viewed as a sunk cost, but the numbers are very low. 60 kilos a ton down to probably as low as 20, depending on how much reuse activity is required. Compared to blast furnace steel, averages of a couple of ton, or electric arc furnace are between 0.3 and 0.7, depending on whether it's X-carb or normal materials. So there's big numbers available to be saved in steel reuse into the projects. I've made the point on here about transport. Steel's carbon footprint is not dependent on its transport cost essentially, and people seem to want local product onto local projects, but steel is moved globally, but so is scrap. So if you reuse the steel, you prevent the scrap from going to the local scrap man to the port, to Turkey, India, or whencever it goes from there, and then duly back again. And we're also creating local sort of employments, businesses and benefits. In terms of steel reclamation, I always like to make this point, or the main point, which is words do matter when you're specifying it. We can still demolish and recover materials. It's about the recovery of materials. It's not about necessarily deconstructing, because that is perceived in the demolition industry as being a spanners, nuts and bolts type activity, and it suddenly starts to jack up the effort, time and cost. So it's a question of what materials can we get out the quickest and the best. Don't create work for work's sake. Don't try and recover the materials that nobody wants. In steelwork terms, the obvious thing there is connections. We're not at a stage of modular design where people are going to take something down and put it back up as it was. So if we spend a very long time trying to unencase end connections and then unbolt them, we've actually recovered something nobody wants to buy later, whereas it could just be smashed out or chopped off above the concrete or whatever. It's that kind of principle. It needs to be thought about at the time. Money. Always a factor. First and very most important point is how volatile steel prices are. Now, I don't just mean because we've got the Ukraine war. We were selling material in 2012 for the same price that we were selling it for in 2022. But the average in between was 60% lower, sorry, 40% lower. It was 60% of that. So for my product, basically, we were selling it at 1,100 quid a ton back in 2012. We were selling it for 1,100 quid a ton at the back end of 2021, but the average for the decade was 650. Scrap's even worse. Scrap has been down as low as £16 a ton and as high as 450 this March. So within a very volatile market, you have to accept there are different opportunities. If steel prices are poor and scrap prices are high, and you do a hell of a lot of work recovering it, it's about break even. So then the argument is about the cost, it's about the carbon cost. However, if steel prices are high, which they are currently, if scrap were lower, which it isn't, you can see there's potentially a very large saving available. But it's about doing the work that recovers things efficiently and economically and sensibly, as opposed to recovering everything. I'm not of the opinion that trying to reuse everything is particularly sensible. So to sum up the advantages there, we've got the cost, if the job's well managed, we've got large carbon savings, we create a local resource, which in the current climate, particularly with energy, but with everything else, a lot of UK steel is imported from abroad. Clearly the material available for reuse is here already. And in reusing it, it is quite labour intensive, and there's a lot of technology and business to be developed in the reuse market to push things forward. There are ourselves and others now in doing this, but I'm sure it'll grow far beyond that. In terms of steel reuse, design is critical. In the primary instance, don't set unrealistic targets. The buildings can't be built out of 100% reused steel at the moment. Make sure your specification is for the building that you want, and then allow for reused materials to go into it. And I would say that applies to any material, not just steel. because any reuse that we get is helping the situation. If the specifications are too tight, the supply chain will rely on that to basically thwart the efforts of circular economy and green aspects later on. If they're too loose, I suppose that's a problem, but you have to be mindful that the spec should allow for reuse where it can occur. So in that regard, design the building you need and then try and reuse. It's not a very good idea to try and find the material and then design a building out of it. I'm seeing that a lot just now. People at RECBE Stage 2 wanting to source materials that they hope are going to be used by the time the building goes up after stages 3 and 4. The design cycles tend to make a bit of a mess of that. And if they don't, you really end up with the potential problem of being inefficient in your structures. So far better to design the building that is the most efficient building and then find reused materials that can be used within it. Not least of which, because if you start cornering a load of reused materials, then in fact they're not efficiently used on your job. If they're 30% heavier, you probably should have recycled them and made new EAF steel out of them. Or equally, in terms of the global emergency, you should have just let the materials go to a job they would have been better used on and got maximum utilization from. It's very difficult in the business environment, however, because people are trying to create publicity, marketing, capital out of green projects. In terms of case studies, which I was asked to provide, I've got to put this one on because we loved it. The Queen's Green canopy, the tree of trees, was actually made from our repurposed and reused products. Weirdly, it was never marketed as such, but that's a different issue. Simple reuse, I think this is critically important. People don't make allowance for the fact that we have to have material in order to sell it, and people knocking big buildings down in London have a habit of only reviewing them from the perspective of what could they use them for. That's not particularly relevant. If you can get the materials out, there will be a market. If the reused material substitutes new, there will be a carbon saving. If we're about circular economy, it shouldn't all be about it landing on our own projects and our own jobs. I can take pretty much any piece of metal and find somebody that will buy it for an application that would otherwise have used new. So in this instance, this is a domestic project. An architect wanted a green development at home. They were knocking a load of walls out. They needed steelwork to hold the roof up. Now, ignoring the fact it was the most colossally chunky steel I've ever seen in my life to stop a 4-bed roof dropping in, because they were so obsessed with deflection. Truth of the matter is they used reused steel rather than new. So there was 3 or 4 tons of carbon saving just in one domestic renovation, just on the steelwork. This is another simple project, Packhorse Bridge in the Yorkshire Dales. Bridge was condemned because the farmer had been running modern vehicles over it. It was all going to collapse in the river. So we were able to provide simple pieces of reused steel to rebuild the deck, to then make the bridge almost hopefully bomb-proof in many years to come. But again, simple application, but we need material coming out of the market to do it. Holbein Gardens, I think this one's been all over the press, but this is another project I love because it was hybrid. They didn't decide how much reused material to put in the job. They just decided they wanted as much as possible. They had some material available. They bought some from us, and the rest we bought and put in as new. But it was really right up until the point where we did the fabrication, where we were putting welding rods to it, where they would allow us to change a new section for a reused section, because there is no reason to distinguish between new and reused in the design unless there are specific aspects or defects that need to be taken account of. So this job actually went very well, and I think it's going to be a big sort of feather in the cap for Grosvenor Estates when it's finished. This is much more basic. This is a wind turbine foundation. 1,400 tons went under the wind turbine, and this was all repurposed oil pipe that came from ourselves. Props and temporary works, actually a very good source of material, but also a big user of material that's often hidden from the construction costs. The demolition guys are now actually reviewing steel coming out of buildings to see if they can use it in their own temporary works or shoring works for things like basement developments. So I know at least 2 of the big players that are now reviewing materials available to them from the demolition to see if they can utilize them at least in the temporary works. So these things are happening. Then we've got the Olympic Stadium, which was, it's a very old headline act of ours now, but 2,000 tons of unused oil pipe that wasn't going to be sold elsewhere was used into the Olympic Stadium. Our own building, a reused frame where we refabricated, repainted it. We were actually able to save 1,500 tons of carbon and nearly £1 million, 25% on the job. But that was also combined with being intelligent about the muck shift and also using road planings. So they were scalping the A19 and resurfacing it. We got 30,000 tons of those scalpings onto our site and substituted them for quarried stone. It made a significant difference, but real point of this job is it was our job, our money, and we were in charge of the whole process. So we were able to dictate how that panned out. And that's me. I'm sorry, that's an incredibly quick presentation, but 10 minutes isn't very long and I can go on for hours. So I hope that's of some interest. And I would say when the Russians, or if we figure out a way of getting our IT back, people are very free to contact me by email or otherwise. We should be live again next week, all things being equal. But I'm very happy to field questions now or answer people's queries after this event. Thanks, Jonathan.
Thanks, Roy. And you're heading off, so I wonder if there were any direct questions for Roy right now, we could take one or two questions.
Yep. No questions is good.
I have a question. Just trying to get my cameras to work.
Okay.
Hello, can you see me?
Good.
Can you hear me?
Yeah.
Yeah, I've got a question. So I've always perceived, rightly or wrongly, that the big challenge to steel reuse is the storage. Is that the thing?
It depends how you want to look at the business model. I have 100 acres of land and 80,000 tons of metal on the ground currently. So at the moment, nobody's offered me enough reuse sections to scare me even a little bit. It's a massive problem when you want to reuse it in your own project. So if you're flattening a 30-story building in London and you're trying to do it within its own footprint, that's a massive issue. But if the material is sold into the marketplace, myself or other players will buy it and store it and ship it back in. And it's really not a big deal. And I go back to my transport point. People get hung up on the fact it's coming out of London going to North Yorkshire. But actually, in carbon terms, I'm not going to say it's irrelevant. It's not irrelevant, but it's not significant relative to not reusing steel.
So there's just basically not enough steel to go into your storage facility.
It's not there's not enough. It's what we are now is a disruptor to the scrap industry. The demolition and scrap industry is incredibly slick. It's very well practiced, and the industry has been reliant on the 95% recycling statistic prior to circular economy becoming a prominent feature. We're making headway now with the demolition guys. We've got most of the large players are now talking to us to help them on bids, for instance, to win work, because clients are asking for circularity in their contracts with demolition contractors. So I can see that this will start to change, but it's a very well-established, efficient route at the moment that has to be disrupted somewhat, and everybody's learning and feeling their way just now.
Yeah, and Roy, I was going to say that I noticed there's an environmental product declaration, an EPD, around reused steel that seems to be driving a huge amount of interest from designers, because you can now verify that reduction in emissions by using reused steel. Are you seeing that come through?
No, absolutely. I mean, we had the LCA for a long time, which gave very similar numbers, and as I say, we've done work that's validated it. But the EPD from EMR has certainly sort of raised it up the flagpole for certain people. But to be honest, a lot of the interest started earlier than that. There really has. I can't exaggerate how the interest has ramped up in the space of the last 10 months.
And just to say, having written on this, in the sustainable materials book, when was that? 10 years ago. It's so exciting to see some of that crazy thinking we came up with, and those of you who are involved with it, is actually now starting to maybe creep into real world.
Well, the other thing, sorry, just very quickly, because I think it's an important point. The other issue anyway is what I was joking with my stepfather. My stepfather's 89 years old. In trying to establish our supply chain for reused sections, we're doing what he did 50 years ago with pipe. And I rebuilt a structure that came out of France and went into Germany 30 years ago. Took down the French Channel Tunnel gantry crane system, stuck it on wagons, took it to Germany, put it up. 5 years later, we changed it from a storage system into a warehouse. we're not inventing a wheel here. We're actually just trying to find the bloody thing after it fell off.
Yeah, exactly. Anne, you had a quick question, maybe?
I don't know if it's quick, but Roy, I was wondering, in your efforts of marketing your products, what are some of the concerns, if any, that people raise for reuse, and what do you do about it?
Weirdly, a lot of the concerns and what I would consider to be the issues aren't always the right pair. So in real terms, the big issue is warranty. So everybody's concerned about who warrants it. But actually, a lot of the industry doesn't understand how their warranty arrives with them for a completed building anyway. So steel can be supplied to a fabricator, and that structure can then be CE marked. And at that point, you've got as much warranty as you would with a new building full of new products. And the other issue I have with warranty is to do with refurbishment. So people can refurbish a 100-year-old building and leave everything in it and be perfectly happy, and everybody's insured and it's wonderful. You take one of those pieces of steel out of that building and put it in a new building, and suddenly everybody's panicking that there's a problem. Steel can be tested really, really well to demonstrate its properties. So the market conditions that we see, those sorts of things. For me, the real issue ultimately is practical stuff. Reused steel will have holes, it will have had attachments. Reused material tends to get shorter each time you use it. So there are physical, practical considerations which are going to trip up fabricators and people like that, or engineers even, if these things aren't properly considered. So some material has to be paired to the jobs. I mean, our repurposed pipe is great because it's all sort of virgin material almost, with very little going on. But the stuff coming out of demolition, I've got stuff in the yard now that's covered in intumescent paint, it's been hacked down with gas cuts, and has got anything up to 30 shear studs welded down it and holes in both ends. If I just turn that round and fire it out the door, somebody's going to have a heart attack. But we can rework it to a usable state, but not to a state of new cosmetics.
Last question, Andrew, because we've got to keep moving. But if you want to have a question.
Yeah, I think one of the issues that we've had as designers is just trying to understand exactly what the potential is, what sort of percentage of steelwork we can reuse in our buildings, and that's kind of exacerbated by how fluid the market is. I mean, is there a way that do you have data that you can share on what sort of sections you commonly have available, or is there a way that we can get sort of up-to-date information on what your stock is? Because it makes it difficult for us to sort of make the case, I suppose, especially if that's critical if it's linked to the actual financing of the project and ESG as well.
Okay, well, there's two issues there. I mean, I can give you a couple. Well, I can because I saw on my laptop. The Russians haven't got it. So I actually have an Excel spreadsheet that has all our inventory in, and as we grow the inventory, we're building that, and that's got a lot of detail about the sections. But the actual issue is, if you're a designer, you're probably asking me about the steel anything up to a year and a half before somebody physically needs it, and that's an issue that we have to address regarding the market and how it works. Because I wouldn't advocate securing material that far in advance. I had a job for 70 odd tons that by the time people had finished doing the connection designs and everything else, about 5 tons of the original size was still on the job, because they'd just gone from stage 2 to, I hadn't even appreciated the issue of connection design until relatively recently. The whole beam job highlighted it quite dramatically. But that particular project did use a lot of green steel in the end, but none of it was the stuff they said they wanted at the start. We just need to get more material into the marketplace and get the market more able to operate like the traditional model of just buy it when you need it. But that's on us to get more material out from the demolition guys.
Great stuff, Roy. The old problem of supply and demand, which I think we've been talking about for many years now.
Yeah, well, the demand's flying, unfortunately. We've got to get the supply sorted out.
Well, if it's demand-led, that it should catch up supply. Great. Thank you again, everyone, for the talks that we've heard, and they've been certainly very interesting. Lots to think about there. Just in this final 5 minutes, I just wanted to open up for anyone who wanted to quickly say any projects that are going on or collaborations that's happening. So maybe just think about that, what's going on in the space, what we're doing looking forward. And I also wanted to announce that Mikhail has got a lectureship, which is great, at Leeds. So clap for him. He's been a long-standing person in this space, and so we're very excited for that. So lectureship in civil engineering in the School of Civil Engineering in Leeds. So all of you know Mikhail. We're very, very excited for him doing that. Projects and things are going on. Simon.
Yeah, thanks, Jonathan. So we're working with Roy on an Innovate UK project. It's under NISA, and I see there's a NISA 2 that's just opened. It's quite small numbers, but we've got quite a nice team working with Grosvenor and ISG and Roy. So if anybody wants to collaborate on a bid there, just drop me a note. And then Roy is speaking at an event. I put it in the chat on the 20th of October, and I can offer, because I'm in a good mood, I can offer all of you free tickets. That's £40 saving to the events on Thursday the 20th. So just drop me a note and I'll put you on my guest list. So simon@asbp.org.uk. Thank you.
Perfect. Thank you, Simon. From our end, we've got, by kind of chance, I've ended up with 2.5 PhDs starting now, looking at building stock, so housing and building stocks in the UK. And Julian has also got a couple of PhDs starting next year. They're doing a master's and then they start in the same space. So that's kind of well connected. So the ones I've got are connected quite heavily in with bays. And looking at really this question of retrofitted buildings, getting them to zero carbon by 2050, and what type of solutions we need, what type of materials we might need to put into that, the carbon emissions of it, etc. So it's not funded by anyone, but we just happen to have lots of good bodies and labour. So we'll start to get some information out about that in time. Was there anything else going on that anyone wanted to mention at the moment?
So from my side, so we managed to open the last presentation, but I think we can leave it to the next session, or to ask Les to record this presentation, and I'm very happy to distribute this presentation across the RECBE members. And from my side, I've 3 months ago, I think I circulated the Google Sheets or Excel spreadsheet with a list of funding streams and different projects. If you know any projects that are relevant for RECBE, feel free to put this project into the spreadsheet for us to have some kind of overview what's happening in the UK, because there's a lot of different things happening. I don't know all of those things, but after the meeting, I will circulate the short summary with the links to the Excel spreadsheet. And Excel spreadsheet is available for everyone. Everyone can just look at the spreadsheet and update or look what's happening there. So that's from my side. And yes. So
Yannick, you got something?
Yeah, if I can get a cheeky plug in for Part Z, just because timing wise, for anyone who's interested in the whole sort of embodied carbon, whether or not that moves into building regs ultimately space, the government response to the Environmental Audit Committee's inquiry around that topic finally came out on Friday of last week, and they've committed to a consultation in 2023 around this. Through the Part Z initiative, which is part-z.uk, I'll drop a link into the thing. We've been trying to coordinate a lot of industry, essentially showing the level of industry support around a set of proposals for what that could look like. We're now up to, I think, over 200 companies, and pretty much all of the professional institutions have put statements of support. If you've not already come across the initiative, please do sign up and support. I'll put a link in there. And there's a private members bill coming forward again for that's up for its next reading in November, which has signatories from 4 different parties on it, and we're currently trying to do a bit of sort of liaising around that. So the more names on it supportive of that, the easier that whole process is. So thanks very much to, I know some of you in the room have already put statements of support in.
Thanks, Yannick, and we can send out an email if we need to through the network to catch more people.
So if anyone wanted to share something within the RECBE network, please feel free to contact me and I will circulate it.
Great. Well, we are out of time unless anyone's got anything burning. So just again to say thanks very much to all our speakers, to Anne and to Ian and to who else? There was Cyril and there was, I'm looking around, someone else. I can't remember. Sorry, my mind's lost me. I'll find it. Wait a second. Roy, who's left us. That's why I couldn't find him on the screen. Really interesting work going on. Great to hear that reuse is taking off, which is great. Really interesting to hear this recycling cement project. And Cyril, we expect you to report back to us if it becomes the big thing, and fund the next RECBE party if it does, because he will probably be richer than all of us. But just to say thank you all for keeping engaging in this activity, and there seems to be good interest, so we'll keep it going. And finally, thanks to Mikhail, who does the bulk of the work to make this happen. So good to see you all.
Good to see you all. Thank you so much for being here today.
Take care.
Thank you.
Thanks a lot. That's brilliant. Right.
Cheers.